Hey kiddos, today we are going to talk about two-step equations with variables on both sides of the equal sign, okay? The mission is still to get the variable by itself. The mission is still to get the variable by itself. So we are going to use inverse operations. We're either going to add or subtract to move the smaller value variable. And then we are going to follow the two-step equation notes for the remaining steps. Those two-step equation notes are already in our journal. We already know how to solve those. Let's start with variables on both sides, okay? First example is 4x plus 7 equals 10 plus x. We're going to use our strategy of the lollipop so that we can separate the sides of the equal sign, okay? Then I am going to combine things or circle and box things that look alike. So this 4x right here has somebody that looks like him on the other side of the equal sign. It's that positive x right there. This positive 7 and that 10 look alike, okay? I'm not saying that they are the exact same. What I'm saying is these are both coefficients. These are both constants. I can combine them. Okay? Now, I am going to use inverse operations to move the smaller valued variable. These are my variables. The one with the smaller value is this x over here. So it told me to use inverse operations. We're either going to add or subtract. Since it's already a positive x or a plus x, we are going to subtract x on both sides of the equal sign. X minus x is 0. I have 10 left over here. 4x minus x is 3x. I still have that plus 7 over there. Okay? Now, if I were to box and circle things now, I have a 3x. Nothing looks like it over here on that side of the equal sign. Here's a constant. Here's a constant. Remember, our equal sign is still in the middle. I moved boxes here because that's where my smaller variable had to go. So now I need to move this 7 to the other side. Now it looks like a regular two-step equation, okay? I'm going to subtract 7 on both sides because that is the opposite of adding 7 here, and I need to get rid of this to get, my variable by itself. So 7 minus 7 is 0. I'm left with 3x here. Bring down your equal sign. 10 minus 7 is 3, okay? Still need our sides separated. Now I need to completely isolate that variable. This 3 and the x are being multiplied together. That 3 is the coefficient of the x. To get rid of it, I need to divide by 3. What you do on one side, you must do to the other. 3x over 3. These 3's cancel out. They become 1. I'm left with x on that side. Bring down your equal sign. 3 divided by 3 is 1. So x would equal 1. Okay, let's try another one. I have 7y minus 2 equals negative 13y plus 3. Circle my equal sign. That way I can see both sides that I'm working on. I'm going to go through and find things that look alike. This that has a variable. This has a variable. Here is a constant. There is a constant. Okay? I need to move or use inverse operations to move the smaller valued variable. Here are my variables. The one with the smaller value is this negative 13y right here, because negative 13 is smaller than 7. So to use inverse operations, since it's a negative 13y, I'm going to add 13y on both sides. Negative 13y plus 13y is 0. I'm left with 3 on that side of the equal sign. There it is. That 3 is what's left. 7y plus 13y is 20y. That minus 2 didn't go anywhere. Now it looks like a regular two-step equation. Okay? Now it looks like a regular two-step equation. Now I know that I need to get rid of that negative 2 right there and that 20 right there to completely isolate the variable. We're going to add 2 on both sides. Negative 2 plus 2 is 0. I'm left with 20y here. 3 plus 2 is 5. To completely isolate the variable, I need to divide both sides by 20 because that 20 is being multiplied by that y. 20 divided by 20, they cancel out. They become 1. I'm left with y on that side. 5 over 20. I can simplify this fraction, and we're going to simplify before we write our answer. I can divide the top and the bottom by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. My y is equal to 1/4. For this problem, y equals 1/4 or 1/4. Okay? Let's look at another example. (5z minus 30 equals 2 times z plus 9. This one is set up a little different. To start this problem, I first need to write out both equations. Or, sorry, not both equations. My mistake. Both mathematical sentences on each side of the equal sign. So here is 5z minus 30. That's already the simple mathematical sentence that I would start with. My problem is here. This 2 is multiplied by everything that is inside the parentheses. So I need to distribute the 2. I need to do 2 times z and 2 times 9. 2 times z is 2z. 2 times 9 is 18. Now I can work. Now we can work. 5z minus 30 equals 2z plus 18. Go through and box things that look alike, circle things that look alike. There's a variable, here's a variable. There's a constant, here's a constant. You need to move the variable, you need to move the smaller valued variable using inverse operations. Here's the variable with the smallest value because there's a 2z and it's smaller than 5z. So we're going to subtract 2z on both sides. 2z minus 2z is 0. I'm left with 18 on this side of the equal sign. 5z minus 2z is 3z. That negative 30 still exists. Just bring it down, or minus 30. Bring it down. Now, I have that 3z. There's no more variables on that side. Here's minus 30 and an 18. Now it looks like a regular two-step equation. Okay? I need to get rid of this negative 30 and I need to get rid of that 3. Let's handle the minus 30 first. The inverse operation of subtraction is addition. I'm going to add 30 on both sides. Negative 30 plus 30, 0. You're left with 3z on the left side of the equal sign. 18 plus 30 is 48. So you have 48 on the right side of the equal sign. Now I got to get rid of that 3. This 3 and the z are being multiplied by each other. We're going to get rid of it using division. Divide by 3 on both sides. 3 divided by 3 is 1. You're left with z here. 48 divided by 3. If you do not know it, go to the side. 3 can go into 4 one time, because 1 times 3 is 3. 4 minus 3 is 1. Bring down your 8. 3 can go into 18 6 times, because 6 times 3 is 18, and 18 minus 18 is 0. So 48 divided by 3 is 16. Z equals 16. Okay? That is solving two-step equations with variables on both sides. Now, you will also see it as a model. You will also see it as a model. Okay? Here's an example of a model that you might see. You can have these rectangles that represent y's or the variable. You can have these small squares that represent positive or negative numbers. They will give you a key. They will give you a key. Your key might look like one long rectangle equals y. A long shaded in rectangle can equal negative y. A small square equals positive 1. Or if it's a square with the negative symbol in it, it equals negative 1, okay? They might give you a key, or they might just give it to you in the picture. They might put plus signs in there and subtraction signs or negative signs there, okay? You just have to pay attention. From this model, you need to be able to write an equation using the model. Here's how. There are 1, 2, 3 y's here. 3 y's. There are 1, 2, 3, 4 positive squares, so plus 4. Bring down your equal sign because it's in the middle. Here we have 1, 2, 3, 4 y's. 4 y's. And then we have 1, 2, 3, 4, 5, 6 negatives. 6 negatives. So the equation that matches this model is 3y plus 4 equals 4y minus 6. Okay? If you have any questions, comments, or concerns, please feel free to email me at my teacher email. You can inbox me on Canvas, or if you are face-to-face, you may ask me in class.